Hey guys, welcome. This is Mrs. Raro and I am going to teach you about function basics. In this video, I'm going to be teaching you about what is a function, and the next video I'm going to be showing you how to evaluate a function. Okay, so let's start with what is a function. So by definition, a function is an input-output device that assigns to each argument in the domain, which are your x values, if you recall back in Algebra 1, to one and only one value in the range, which is your y value. All right, so that's the definition of function. So functions are represented in many different ways. So these are the four basic ways that you can represent them. You can represent them as a map. All right, so a map is also called a mapping diagram, and it just basically separates your domain x values and then your y values. In this story, Pam is scoring, say, 16 points. Say this was a basketball game. Juan is scoring 14 points, and Talia is scoring 17 points, which is possible, right? So each domain is assigned to one and only range. Let's take a look at a set of ordered pairs, all right? It can also be represented as a function if each domain is assigned to one and only one value in the range. So let's take a look at negative 2 comma 8, negative 1 comma 1, 1 comma 1, and 2 comma 8. So this is a function because each domain is assigned to one and only one value in the range. Although you see the y values repeat here, the x values don't repeat. And let me explain it back to the map here, right? So let's take, for example, Pam. Pam right now currently is scoring 16 points. Juan is scoring 14 points. But in a single game of basketball, can Pam score both 14 points and 16 points? Could that be possible? The answer is no. In a single game of basketball, Pam can't score 14 points and 16 points at the same time. So in this mapping diagram, this wouldn't make sense. Therefore, this wouldn't be a function if Pam was scoring 14 points and 16 points, right? So let's say the domain here was 2. So 2 comma 14 and then 2 comma 16 cannot be a function because the domain here is assigned to two values in the range. Okay, now let's take a look at a different way. All right, let's say Pam has 16 points and Juan also has 16 points. Sorry about that. All right, and Juan also scored 16 points. Is this now a function? Right? So say Juan doesn't score 14 points, right? So if Pam is scoring 16 points and Juan is scoring 16 points, so P is for Pam, J is for Juan, and then here's the number 16 for our range. So that could be a true story because in a single game of basketball, you can score the same amount of points. So in replacing P and J with the number, say, negative 2 and positive 2, this is a function because negative 2 in your domain is assigned to one range, and then positive 2, a different domain, is assigned to the same range. Okay, so that is a function. Let's take a look at another way to represent a function. Could be represented by a formula or a rule, right? It could also be represented by a graph. All right, so we're going to take a look at different ways to represent and identify what's a function and what's not. All right, in a graph, it's easy for you to perform what is called the vertical line test. So the vertical line test is used to determine if a graph represents a function. If you imagine a vertical line parallel to the y-axis and you move it left or right, you would be able to determine if that graph is a function or not. If the line hits the graph in one and only one point on this graph, for all the vertical lines that touch the graph, then that graph is a function. So for example, if I move this ruler, right, so here, say I move it here, all right, so as you can see, wherever I move the ruler, it's only hitting one part of the graph. Okay, so every time I move this ruler, say here, it's only hitting one part of the graph. Okay, so wherever I move this ruler, it's only hitting one part. And that's how you can tell from a graph perspective that that graph is a function. So let's take a look at different examples, right? So I have two examples here. This red graph right here is this equation, and then this blue graph right here is this equation, right? So again, if I perform the vertical line test by moving this left or right, we can identify what is a function and what is not. All right, so let's take a look at this graph, right? So if I place this vertical line, you can tell that this is not a function because it crosses this graph vertically twice, all right? It could be twice, 3 times, 4 times, it doesn't matter, just nothing more than 1. All right, so this is not a function. Okay, let's take a look at this graph right here. Right, so if I move it here, it only touches it once. Again here, just once. And wherever I move it, you can see that it really is only touching this blue graph just once, right? So this is a function. And that is called a vertical line test. I'm sorry about that. Okay. So this is a function. All right, and that is called the vertical line test. Okay, now let's test your knowledge and see if you're getting these questions correctly. So let's pause the video real quick and then read the question. And in 3 seconds, I will reveal the answer. Okay, so the question is the relation a function? 3, -1, 6, -2, and 9, -3. Yes, no, or I need help, right? So the answer is yes, it's a function, right? Because we have every domain, each domain only is assigned to one range, okay? All right, let's take a look at the next example. Let's put it back. All right, again, let's pause the video real quick and let's see if we can answer this question. Okay, so it's the finite relation in the table, a function, right? Yes, no, or I need help, right? So we have -2, 3, 0, 2, -1, -1, 3, 2, and -2, 0. So let's see the answer. Okay, so the answer is no, because if you put it in a mapping diagram, you could see that -2 here repeats. -2 is assigned to 2 y values. -2 is assigned to +3, and -2 is assigned to 0. Okay, let's put this back, and let's take a look at our next example. Right, so again, a mapping diagram is this following a function. Please pause the video and let's see if you can answer this question. Okay, let's take a look at the answer. And the answer is A, yes it is, because each value in the domain is assigned to only one and only one value in the range. Okay, hopefully you're getting in the hang of it. Let's take a look at another example. All right, this might be my last example. So the question is the graph of the relation a function? Right, so pause the video and let's see if you can answer this question. Okay, let's take a look at the answer, and the answer is a yes, because if you perform the vertical line test, so I'm going to draw you a vertical line right now. I'm going to make it green. Okay, so here's a vertical line. All right, I'm going to move that around, and it doesn't matter where I move it. You can tell that it's only hitting the red graph once. Okay, and I think that is it. Thank you for watching.